All right, guys, this is to show you how to do the crisscross method for ionic compounds. Remember, this is for ionic compounds only, which means you have one metal and one nonmetal. All right, one metal and one nonmetal. Don't forget that hydrogen is actually a nonmetal. Okay, so one metal, one nonmetal. So I've got a couple examples here: lithium phosphide, calcium bromide, and calcium oxide. I'm going to show you the traditional method where you show valence electron transfer, and then I'm going to show you the crisscross for each of these. So starting off with lithium phosphide, here's lithium here with one valence electron. And here is phosphorus with 5 valence electrons. All right, so it's not full. It's got 5. So this one wants a few more. This one wants to get rid of the ones it has, so it transfers over. This gives this one 2, 4, 5, 6. It's not full yet, so another lithium comes along because this one's already, now it's got a full energy level. It's gotten rid of its outer electron. So we're going to let this one do the same. So this lithium's happy. This one's happy. It's got rid of its outer electron. Now it has a full valence shell, but this one's still not happy because it's got 2, 4, 6, 7. We're almost there. We add another lithium and we allow that to donate. Now all the lithiums are happy and the phosphorus is happy as well. Okay, so that's the kind of traditional method. And you would have counted how many LIs you had. So 3 lithiums. And how many phosphoruses you had? 1 phosphorus, Li3P. How you do this for the crisscross is you use the charges. So instead of the valence electrons on top, we come down here to the charge. Lithium has a +1 charge, and phosphorus has a -3 charge. So +1 and -3. So lithium with a +1 and phosphorus with a -3. And you're going to crisscross the numbers, just crisscross the numbers. So just the 1 and the 3. Notice I didn't select the plus or the minus. You're just crisscrossing the numbers. So the 3 would come down here, and the 1 would come down here. Rewriting that would be Li3P with an imaginary 1. We don't write the 1 in. So either way, you can do this, the crisscross method and the drawing method. Okay, let's try calcium and bromine, calcium bromide. Here we go. Calcium has 2 valence electrons. Bromine has 7 valence electrons. So 1, 2, and then 1, 2, 3, 4, 5, 6, and 7. We're going to go ahead and let it transfer. So the bromine is now happy. It can't take any more electrons. It's got 2, 4, 6, and 8. All right, so now we're going to actually bring another bromine in since the calcium's not happy yet. It wants to get rid of that one too. 4, 5, 6, 7. And we're going to allow it to transfer down. Now it's got 2, 4, 6, and 8. So this guy's happy. It's got a full shell, and full shell. Just like before, we count how many I have. So 1 calcium. Count how many bromines I have. We have 2. The crisscross method, again, looking at the charges. So here is my calcium with a +2 charge. Here is my bromine with a -1 charge. So +2 and -1. Same technique as before. Circle the number, not the sign, not the plus or the minus, and cross it. So the 1 would come over here, and the 2 would come over here. So we would get a Ca with an imaginary 1 and a Br with a 2. Either method. All right, I'm going to show you a slightly more complicated one, only slightly, and the drawing is going to help you see why. All right, so we've got calcium, which we already said has our 2 dots, and we've got oxide, that's oxygen, and that's got our 6 valence electrons. 1, 2, 3, 4, 5, 6. All right, calcium transferred. Oxygen's not full yet. It still wants 1 more electron, but guess what? Calcium still wants to get rid of an electron. So when we do it the drawing way, we can see that we used 1 calcium and we used 1 oxygen, CaO. When we do the charges, so just like up here, we said calcium was a +2. Oxygen is a -2. So we're going to circle the numbers and cross, just like before. So the 2's would come down there. So you would think that our answer is Ca2O2. But if the numbers can be divided, you have to divide them. So basically, both of those are going to become a 1 instead. So if it was 4 and 2, it would be 2 and 1, for example. You want to reduce the compound. So this would actually be CaO as well. Okay, so in this case, the drawing may have actually helped to see, like, oh yeah, you actually only needed one of these and one of these to completely balance the charges. This might have been harder to see. So Ca2O2 would have reduced to 1 and 1, so CaO as well. I hope this helps, and if not, email me questions.